In the next century, how will we heat our homes? How will we fuel our vehicles? In 2052, we will not have any more oil. In 2060, no more gas. In 2080, no more fossil fuels. It is imperative that we find some energy alternative. Because of this, the National Academy of Engineering has posed a challenge to make solar energy more economical.
In the next 50 years, it is expected that oil reserves will dry up, and a major supplier of energy to the world will cease to exist, with other fossil fuels following shortly after. Unless we wish to descend back into the horror of medieval energy constraints, we will require alternative energy sources. One of the energy sources that appears to be viable is solar, the production of energy using sunlight with few or no intermediary steps, such as plants or heating-induced currents and fluids. Without a new source of energy, basic things such as the internet, electric lights, air conditioning, food, and cars will become defunct memories of a better time. Of special importance, food production relies heavily on petroleum in the form of fertilizer, farm equipment, etc. Without petrol or synthetic products that serve a similar function, half of the world's population would starve to death. The entire world would be wrapped in famine and war over the little remaining oil.
Developing nations will require massive amounts of energy as they grow in the near future, and going by the current trends, they will be caught up in the trap of oil that many developed nations will need to dig themselves out of, creating a greater problem than what already exists.
The challenge is to make solar power cheaper and more attractive to developing and developed countries alike. It is also necessary to make solar energy collection more effective and to improve methods of storage.
One viable method to solve the energy crisis is unrelated to solar panels entirely. Instead, humans could conserve sunlight via high-intensity mirrors directed at a tank of water, causing the water to boil and essentially creating a boiler out of light rays. When the water boils, steam escapes and powers a turbine, which, in turn, creates an energy source first utilized in steamboats in the industrial era. The efficiency of these turbines ranges from 40 to 50%, and is more forgiving to the environment, decreasing the need for fossil fuels. A few problems with this is that not every country, particularly developing countries, has access to large amounts of water, and sunlight is sparse in many regions of the world.
Another solution to improving solar efficiency is to improve the chemical and physical composition of solar panels. The current method of obtaining solar energy is through the use of the photoelectric effect, in which a photon strikes an electron of the solar cell, which is collected by a circuit inside the solar panel. There is unusable excess heat given off by this interaction, which limits the maximum efficiency of the cells. Lead selenide nanocrystals have sometimes been found to give off an extra electron instead of this heat, which creates a gain in efficiency of 37% over the theoretical max efficiency of the older collection methods. The cost of lead selenide nanocrystals is 8 times greater than silicon nanocrystals. However, this cost would likely be offset by the gain in efficiency and the smaller number of cells needed to collect energy over time.
We chose this challenge not only because we were interested in renewable energy sources, but because fossil fuels are depleting and environmentally destructive. Solar energy can provide a clean way to keep up with the world's energy consumption.